originally planned to make a video on how to scientifically pull all-nighters or how to recover from sleep deprivation. But after reviewing massive amounts of research and consulting with 3 PhDs in sleep science, I realized I was crazy. What made me think that a few trivial tips could override a product of millions of years of human evolution? It's because we don't truly understand sleep that we keep lowering its priority in our lives. So we're using about 10 minutes to thoroughly explain what sleep actually is, what damage sleep deprivation causes, what interferes with our sleep, and how to genuinely improve sleep quality. We'll present the most rigorous scientific evidence and current mainstream views to unveil the truth about sleep. How do you know you've fallen asleep? Is it when you can't sense the outside world, or when you wake up and realize hours have passed? But anesthesia and coma can do the same thing. In fact, sleep isn't your brain shutting down and losing consciousness. It's far more complex than we imagine. In 1952, University of Chicago grad student Eugene Aserinsky and Professor Nathaniel Kleitman made possibly the most important discovery in all sleep research. Aserinsky was recording infant eye movement patterns during sleep. He noticed during certain stages the infant's eyes moved rapidly beneath the eyelids. At these moments, the infant's brainwaves were almost identical to those observed when fully awake. Between these active sleep stages, there were periods when eyes stopped moving and brainwaves became calmer and slower. Even more remarkable, these 2 sleep stages repeated throughout the night in a regular pattern again and again. He told his advisor Kleitman about this. The professor thought he couldn't fully trust other people's kids, so he decided to test his own daughter to verify. The results were identical. Based on eye characteristics, they named these 2 sleep stages Rapid Eye Movement Sleep (REM) and Non-Rapid Eye Movement Sleep (NREM). Now we know sleep consists of these 2 modes alternating in cycles. But that doesn't seem particularly groundbreaking. That's because I haven't explained yet the brain waves I mentioned earlier. During sleep, massive numbers of neurons transmit signals. Using electrode devices, we can capture these signals. In different states, brain waves vary, allowing us to assess brain activity. During sleep, your brain waves fluctuate slowly one moment, then look just like when you're awake, and every 90 minutes or so completes this switch. This means during sleep, our brain is definitely doing some secret activities behind our back. So what exactly is it doing? In 1924, 2 German researchers, John Jenkins and Karl Dannenbach, conducted an interesting experiment at Cornell University. They recruited college students and had them learn a series of verbal information. One group stayed awake the whole time, while another group slept through the night. The result was sleep helped consolidate vast amounts of new information, while staying awake caused massive forgetting. Of course, by today's standards, this experiment was quite crude. But countless subsequent related experiments found sleep indeed helped store and strengthen newly acquired memories. So, how exactly does sleep accomplish this? When we're awake, the brain constantly absorbs external information. This data gets temporarily stored in a brain region called the hippocampus for short-term storage. The hippocampus is like a cache used to accumulate new memories. But its storage capacity is limited. If it exceeds capacity, you risk being unable to add more information. Like cramming all night, sometimes nothing sticks no matter how hard you try. You memorize the end and forget the beginning. Memorize the beginning and forget the end. Like data on a hard drive being repeatedly overwritten. So how does your brain handle this data dilemma? One crucial method is sleep. When you're in deep non-REM sleep stages, this data transfers from the temporary hippocampus storage to the cerebral cortex, long-term memory storage. This process both saves the data and clears the hippocampus cache, creating enough space to begin the next day's new learning. From this perspective, burning the midnight oil studying, is it really effective for students learning? Non-REM sleep strengthens individual memories. So what does REM sleep provide us? Dreaming. Don't underestimate dreaming. Some of history's major discoveries have deep connections to dreams. Russian genius chemist Dmitry Mendeleev was obsessed with finding the organizational logic among known elements in the universe. This quest was tactfully described by some as searching for God's abacus. He made a deck of cards, each card representing a common element and its unique chemical and physical properties. Then, regardless of time or place, he constantly shuffled and rearranged, then shuffled and rearranged again trying to deduce the rules hidden behind these elements. After years of nearly maddening contemplation, Mendeleev had no success, until one night he found the answer in a dream. In Mendeleev's own words, "I saw a table in my dream where all elements fell into place as required. Upon waking, I immediately wrote it down on paper. It seemed only one spot needed slight correction. Although some questioned whether only one spot was corrected, no one doubted that Mendeleev was inspired by his dream to complete the periodic table. The double helix structure of DNA also appeared to James Watson in a dream, Paul McCartney's. Yesterday, the melody came to him in a dream. Even the Google search algorithm concept was conceived by Nobel laureate Otto Loewy, who designed his famous frog heart perfusion experiment in a dream. In dream-rich sleep states, the brain carefully processes vast acquired knowledge in abstract and novel ways, mixing memory elements together, fusing them, and performing special intelligent information processing. This can spark creativity and enhance problem-solving abilities. But please note, don't just daydream. You won't just lie in bed dreaming and come up with a second periodic table. Scientists received dream inspiration because before having these dreams, they'd already conducted countless research and contemplation. Don't put the cart before the horse. Sometimes people's dreams are too bizarre. To prevent your body from acting out dreams, the brain sends a powerful blocking signal. Muscles instantly lose all tension and strength. This design is incredibly clever. The brain paralyzes the body, letting you dream safely. Otherwise, if you dreamed you had invisible wings, you might actually try flying freely in reality. When REM sleep ends, your body is released from its imprisoned state and rescued, re-entering non-REM sleep. I know you're thinking of sleepwalking, but this sleep disorder occurs during non-REM sleep. Why exactly does this happen? Current medicine cannot explain it. To summarize regarding information processing, when awake, you constantly receive external information. Non-REM sleep helps store and strengthen newly acquired memories. REM sleep connects this new information with all past experiences, and during this process performs intelligent information processing, enhancing innovative insights and problem-solving ability. But knowing all this, will it convince stubborn you to obediently sleep? I doubt it. So next, let's discuss the harms of sleep deprivation. First is lack of focus. Sleep deprivation's most direct side effect is inability to concentrate mentally. Zone out in math class and you're lost. Doze off during the boss speech and you forget to applaud. Among these, drowsy driving is most serious. When fatigued, people easily nod off, sometimes lasting only a few seconds. But these few seconds cause 8 times more traffic accidents than drunk driving. The reason is simple. Drunk drivers have alcohol-numbed brains, causing slow reactions. But when you nod off, you completely stop responding. Sleep is also linked to Alzheimer's disease. During sleep, cerebrospinal fluid clears the brain's daytime metabolic waste from neural activity, including beta-amyloid protein associated with Alzheimer's disease. Sleeping too little in adulthood significantly increases Alzheimer's risk. Hope you don't end up with dementia while still young. Former British PM Margaret Thatcher and former US President Ronald Reagan both proudly claimed to sleep only 4 to 5 hours nightly, boasting about it. Then, they both without exception developed Alzheimer's disease. Trump constantly mocks Biden for senility, but he himself is also someone who loudly proclaims sleeping only a few hours nightly as a short sleeper. Suddenly, I have a bold prediction. If my prediction comes true, let me know in the comments. Sleep is also linked to emotional control. A brain structure called the amygdala is a key site for generating intense emotions and stress responses. Sleep-deprived participants show amygdala emotional responses increased by over 60%. Why does this happen? Scientists discovered through research that after a full night's sleep, the prefrontal cortex managing rational logic forms strong connections with the amygdala, exerting inhibitory control, regulating this deep brain emotional center. Without sleep, the strong connection between these two brain regions doesn't exist. We lose control over our emotional accelerator, suddenly becoming very irritable and anxious, then suddenly slow and dull in response. Emotions can undergo huge changes in very short periods, switching between emotional extremes. This extreme state causes immeasurable damage to the human body. Some data shows sleep deprivation is linked to childhood aggression and bullying behavior. Abnormal sleep is associated with depression, anxiety, PTSD, schizophrenia, and bipolar disorder. Of course, having sleep problems doesn't mean you'll definitely have mental issues, but between the two, there's undeniably a connection. Besides this, sleep deprivation also causes weakened immunity, increasing cancer risk. Starting in 2019, shift work and night shifts were classified as Class 2. A carcinogens by WHO, sleep deprivation can also trigger cardiovascular disease, cause sudden death, lead to hormonal imbalances, induce obesity and diabetes, and may affect the reproductive system, causing ED. Sleep plays a pivotal role in human life activities. This is why, through evolution, humans spend 1/3 of their time in this state that's neither productive nor defensive. When hearing about a drug that enhances memory, boosts immunity, lowers cardiovascular risk, reduces obesity, depression, and anxiety, we'd rush to get it, treat it like a miracle drug. But when told you've always had it and it's permanently free, humans don't know how to cherish it. We always seem to be this way. Occasional all-nighters can be self-regulated by the body, but chronic sleep deprivation will cause various problems. In the next video, we'll tell those wanting good sleep what's interfering with our sleep and how to genuinely improve sleep quality. Hope everyone watching can sleep well and have sweet dreams.